Finally, let's see what effect connecting capacitors has on a circuit and see what the different types of capacitors are. Like other electronic components, such as resistors and inductors, capacitors can be connected together in circuits. When capacitors are connected in parallel, the total capacitance increases because the plate area has increased. To find the total capacitance, you simply add the individual capacitances together. This is expressed by the formula C sub t equals C1 plus C2 plus C sub n. In this circuit, two capacitors are connected in parallel. The value of the first is 4.7 microfarads and the second is 10 microfarads. Total capacitance for this circuit is therefore 14.7 microfarads. As capacitors are connected in series, the total effective dielectric or plate thickness increases. Therefore, the total capacitance decreases. This gives us a reciprocal formula, and we add these reciprocals just as we added resistors in parallel. This is expressed by the formula 1 over C sub t equals 1 over C1 plus 1 over C2 plus 1 over C sub n. The reciprocal of the total capacitance equals the reciprocal of the first capacitance plus the reciprocal of the second capacitance, and so on for all the capacitors in series. In this circuit, two capacitors are connected in series. The value of the first is 4.7 microfarads and the second is 2.2 microfarads. Total capacitance for this circuit is therefore 1.5 microfarads. Capacitors come in many different shapes, sizes, colors, and kinds. But no matter what their color or shape, all capacitors are classified into one of two basic categories, polarized or non-polarized. Polarized capacitors are used for high-energy storage applications. They are large-value capacitors. These range from 1 microfarad up to 1 million microfarads of capacitance. Polarized capacitors are also called electrolytic, which refers to the way the capacitor is constructed. An electrolytic capacitor begins with a very thin oxide layer coating on one side of a foil conductor. This foil is the positive electrode. The oxide coating functions as the dielectric of the capacitor. An electrolyte-coated separator keeps the positive foil plate from the other foil layer, the negative capacitor plate. The sandwich of layers is then rolled to pack the plates into the smallest possible space. Polarity must be observed when inserting an electrolytic capacitor into a circuit, otherwise disastrous results may occur. The symbol for a polarized or electrolytic capacitor always marks the straight plate positive. This means that you should always connect it to the positive side of the voltage source and connect the curved side to the negative or less positive side of the voltage source. Non-polarized capacitors come in several different types, depending on their shape and the dielectric they use. Non-polarized capacitors are small-value capacitors. Typically, capacitors less than 1 microfarad are non-polarized. Disc capacitors, as their name implies, are circular-shaped. Their dielectric is normally made of a ceramic material. A second group of non-polarized capacitors are layered capacitors. Layered capacitors normally have a rectangular shape. They have several different sets of plates with a mica or ceramic dielectric between them. Another type of capacitor is the film capacitor. Film capacitors can be tubular or oval-shaped. They use flexible dielectrics, such as plastic or paper, that, like electrolytic capacitors, can be rolled to conserve space.